Good day and welcome to my tutorial today about exponential growth and exponential decay. We have the following objectives. Number 1, differentiate exponential growth from exponential decay. And number 2, analyze and solve problems involving exponential equations. Let's have exponential growth first. We have the following definition and the idea pertaining to exponential growth. If a quantity increases by the same proportion r in each unit of time, then the quantity displays exponential growth. For example, if a population of rabbits doubles every month, we would have 2, then 4, then 8, 16, 32, 64, 128, and so on and so forth. A quantity is growing exponentially if it increases by the same percent in each time period. So this is our formula that we're going to apply when we are solving exponential growth. A is equal to P, open parenthesis, 1 plus R, close parenthesis, raised to T. So A stands for amount after time. P means principal, the starting amount or the initial number of whatever the problem is talking about. T refers to time after the starting point, and R is the decimal increase or percent divided by 100. Let's have example number 1. You deposited 15,000 pesos in an account that pays 2.3% interest compounded yearly. How much will you have after 2 years if you didn't deposit any more money? So here 15,000 is the principal, 2.3% is the rate, and 2 years is the time. 2.3% is the same as 0.023. Now, let us solve the problem by applying the formula. A is equal to principal times 1 plus R raised to time. Let us replace P by 15,000, the initial amount that you deposited, times 1 plus R. Our R is 0.023 plus 1, so this will become 1.023, and then raised to time, which is 2 years. Solving this will give us 15,000 times 1.023 squared is, let me use my calculator, 1.023 squared is equal to 1.046529, and then multiply the result by 15,000. I have here in my calculator 15,697.935. Now let's round this off to the nearest whole number, and this will become 15,698 pesos. So this will be the amount of your money after 2 years. Let's have example number 2. A population of 20 rabbits is released into a wildlife region. The population triples each year for 5 years. What is the population after 5 years? So a population of 20 rabbits, 20 is the initial number of rabbits. So this will be our P. And then 5 years. What is the population after 5 years will be our time, and our ratio, we don't have any percent here, but the word triples here is telling us that this is our R. Let us again enumerate the given. So P is equal to 20 rabbits, R is 3, and time is 5. Using the formula, A is equal to P times 1 plus R raised to T. equals, replace P with 20 times 1 plus R. We don't need to use this because there is no percent. Use this only if there is percent. So instead of 1 plus R, let us replace it with 3. This is our ratio here, and raised to time, which is 5. So this will be 20 times 3 to the 5th is 243. And then multiply by 20, it's 4,860. 4,860 rabbits after 5 years. So this is our answer for this problem. Let's have example number 3. Your business had a profit of 25,000 in 2010. If the profit increased by 12% each year, what would your expected profit be in the year 2020? So here, 25,000 is the principal, 12% is the rate, which is the same as 0.12. Now, from 2010 to 2020, that will be 10 years. So, time, therefore, is 10 years. Now, let us solve using the formula. A is equal to P times 1 plus R raised to time. P is equal to 25,000 times 1 plus R is 1 plus 0.12. This is 1.12. And then raised to time, which is 10. Now, let us solve. 1.12 raised to 10 multiplied by 25,000. Using calculator, the result is 77646.20521. Now, let me round this off to the nearest whole number, and this will be 77,646 pesos. This will be the profit in the year 2020. So again, from 25,000 pesos profit with 12% increase per year, this will be the amount or the profit after 10 years. Now, let's have exponential decay. We have the following definition and big idea regarding exponential decay. If a quantity decreases by the same proportion r in its unit of time, then the quantity displays exponential decay. Example, atmospheric pressure. The pressure of air around you decreases as you go higher. A quantity is decreasing exponentially if it decreases by the same percent in each time period. Now let's have the formula for exponential decay. We have A of t is equal to P times 1 minus R raised to t. So AT is amount as a function in terms of t. P is the principal or the starting amount. T is time after the starting point. And R is the decimal decrease or percent divided by 100. So everything is exactly the opposite of exponential growth. Let's have example number 1 for exponential decay. Your father bought a new car for 600,000 pesos. The car depreciates at the rate of 7% per year. What will the car be worth after 10 years? So let's identify the given. 600,000 obviously is the principal, so 600,000 pesos. For the rate, we have 7%, which is the same as 0.07. And for the time, we have 10 years. Now, let's apply the formula. A is equal to principal times 1 plus R. Sorry, it's not plus anymore because it's exponential decay. It should be minus. So 1 minus R raised to time. For the principal, let's replace it with 600,000 pesos. times 1 minus r should be 1 minus 7%, or 100% minus 7% is 93%. So 100 minus 7% is 93%. So this is 0.93, which is our decay factor. So let's put here 0.93, and then the given time is 10. Let's replace t with 10. Let's solve this. 0.93 to the 10th power using calculator, and then multiply by 600,000 will give us 290,389.3843. Now let's round this off to the nearest whole number, or to the nearest peso. This will be 290,389 pesos. This is the amount of the car after 10 years. So it's very, very low compared to the amount when the car was newly bought. So of course, the value is decreasing because it depreciates by 7% per year. Let's solve the second example for exponential decay. A total of 10,000 bacteria cells were initially present at the start of an experiment. These bacteria cells were placed in a condition that inhibits decay. After 5 hours, there were only about 7,000 cells. How many cells are left after 10 hours? Now, let's identify the given. First, we have 10,000 bacteria. So this is the initial number of bacteria. Let's call it A sub 1. If we're going to recall the lesson about geometric sequence, because exponential decay is related to geometric sequence. So A sub 1. Then after 5 hours, there were 7,000 bacteria cells. So this is A sub 2. What is it telling us? If we have A sub 1 and A sub 2, and we do not know the rate because rate is not given, we cannot see any percent here, we can apply the previous formula that to get the rate or the ratio, we need to divide A sub 2 by A sub 1. So here, our A sub 2 is 7,000. 7,000 divided by A sub 1, which is 10,000. This will give us 7 over 10, or 0.7. This is already the decay factor. Decay factor. So this is the ratio, the 1 minus r that is in the formula. What else do we need to find? It's the time. So let's analyze. Initially, there were 10,000. Then after 5 hours, there were only 7,000. And the question is, how many cells are left after 10 hours? If the required time is after 10 hours, a matter of 5 hours again after 7,000. So we are looking for this amount, for this number of bacteria after 10 hours. So if you notice, from 0, then 5, 10 hours. A matter of 5-hour interval. And we have only 2 intervals here, which is our time. So 2. It's not 5, it's not 10 that we're going to put for time. Instead, it should be 2. It's a matter of interval. So from 0 hour, then after 5 hours, 7,000. Then after 10 hours, another 5 hour after the second, after 7,000 here. So it means to say time is 2. Or simply divide 10 by 5. So here in the given, 10 divided by 5 will give us 2 also. Now we have complete given, we have P, we have time, and we have R. We can now solve this. So A is equal to 10,000 times 1 minus r is already 0.7. So 0.7 raised to time, which is 2. So let's solve this. 0.7 squared. 0.7 squared is 0.49. This is 0.49 and then multiply by 10,000. Simply move the point here 4 places and that will be 4,900. 4,900 bacteria cells after 10 hours. So this is the final answer. I hope it's clear. Let's have example number 3. A total of 10,000 bacteria cells were initially present at the start of the experiment. These bacteria cells were placed in a condition that inhibits decay. After 2 hours, there were only about 5,000 cells. How many cells are left after 10 hours? This problem is similar to number 2. I just changed the number of bacteria to 1,000, the number of hours, and the number of cells. So I changed the number, but the same concept, the same analysis that we need to apply. So here 1,000 is the principal, and again we cannot see any percent, so we have to look for R for the ratio, and we have to look for the time because 10 nor 2 are not the correct time for us to put. Now let us analyze the problem. 1,000 initial number of bacteria at the start, so meaning 0 time, and then after 2 hours, the 1,000 becomes 500, so it becomes half. Now we are asked after 10 hours, so for us to go to 10 hours, we need how many intervals? So from 2, the next is 4, and then next is 6, and the next is 8, and finally 10. So after 2 hours, 500, after 4 hours, 6 hours, 8 hours, and 10 hours. A matter of how many intervals yan? So 1, 2, 3, 4, 5 intervals. And that 5 intervals is telling us time. Or simply divide 10 by 2. So that's the shortcut for us to get the time. 10 divided by 2 is 5. This will be our time. Now next, for us to get the ratio, like what we did a while ago in number 2, simply divide the second term by the first term. So this is 500 divided by 1,000, which is 1/2 or 0.5, 50% or 0.5. Now we can solve. A is equal to 1,000 times 0.5 raised to 5. So 0.5 raised to 5 is 0.03125, and then let me multiply it by 1,000, 31.25. 31.25, or let me round this off to whole number, 31 bacteria in all. So after 10 hours, there will only be 31 bacteria. Let's verify whether 31 is correct by doing it manually. If you notice, it's a matter of half. So half of 500 is 250, half of 250 is 125, half of 125 is 62.5, and half of 62.5 is 31.25. 31.25, and finally this 31.25 is after 10 hours, which is the same as our answer when we use the formula. Therefore, there will be 31 bacteria after 10 hours. So this is the last problem under exponential decay, and I hope you understand